you, everyone. I appreciate your time. And this is Zach Pitlock. I'll be joined by my colleague, Shrikant Sarangi. And Shrikant is the real engineer on the project. And we're kind of presenting, as I think Vinny once told me about 4 years ago when we first joined Allotrope, that people don't quite need us yet, but it's important for them to know about us. So that's probably still the context. So we're going to talk today about enabling faster and more cost-effective data management using flexFS with Allotrope data format files. And the topics that we'll be covering, I just wanted to put up as an exemplar from the literature, an article from Digitization and Drug Substance Manufacturing. It was published by Genentech and Bonnie Shum at Genentech. And then we'll go into an overview of Flex use cases with the Allotrope data format, and then some data storage and querying challenges and conclusions. So Bonnie had this great figure, which I think captures a lot of what's already been described aspirationally by the Pistoia Alliance and others. Is that, right now you're in a very reactive, responsive mode, description analytics and diagnostic analytics. And everyone wants to get to the point of having, prescriptive analytics, where you can really decide how to modify methods and reduce out of spec and out of tolerance measurements and improve your costs, right? So in the article that Bonnie wrote, she had this beautiful figure, which where Paradigm 4 is really focused on the middle bit, the analytics environment. We've heard a lot about, how to coordinate the storage of methods, and saving of results in the appropriate file format. But our goal really is to understand the analytics environment, and especially today we'll talk about the green box, the so-called data connections and APIs to support the analytics environment. And we've learned the hard way why this is really, really important. Because if you want to conduct some large-scale learning and neural network type of analysis, then moving data around all of a sudden becomes a huge cost. And like I said, we've learned the hard way in doing this with genomics. So finally, I just want to acknowledge, and I think it's nice to have this the paper as a reference, that of course, once you've solved the riddle of getting everything to talk to each other and all the data analytics to work, then of course you can go into the fine art of comparing methods and selecting parameters and optimizing. So, and then the last educational slide, which I think is really important, and this stays with me. This was given to me by Brent Donovan, who, when he was at Merck, and I was working in the field of inhaled medicines, and this is it's a nice summarization of why it is that large-scale data analysis truly becomes important in quality control and in improving processes. And what you see here is a chart of particle median diameters. It's from a different method than LC, and what's the important parts of the fact they have many observations along the x-axis, as you can see, and you really come to grips with the fact that many manufacturing processes have scatter in their data distributions, and that you really have to account for that in designing and setting incoming material specifications, as well as in intermediate specifications and finished product specifications, so that all of this wonderful work that Allotrope and Pistoia and vendors like Agilent, Zontal are doing in order to make it possible to interchange data and to store data usefully for analysis, it all boils up to this, which is at some point you're going to want to be doing historical analyses and improving your methods, or at least defending them to the regulators. And these types of charts, where you're looking at the CPK in this case, are really, really important. So just hopping into the world of big data then, we have, at Paradigm 4, of course, we have this technology, which is a database software. So for us, there are data sets and then database software. So we're loath to say a collection of files is a database, it's a data set. And that's kind of the terminology that we use. So with SciDB, you do all kinds of interactive querying, and we've shown this in the past. But what we ran into in terms of scaling big analyses was cost. And it's a surprising topic. People don't talk about when they're dealing with onesie twosies, but when you're dealing with data on the scale of millions of files, all of a sudden cost becomes a huge effort. So the other challenge, of course, is to make the algorithm scalable, and that again oftentimes hinges on actually moving data, right? So kudos to the Allotrope Foundation for helping to solve this file redundancy issue. That's a huge problem, so that you can have one type of file and not 20. And then, you know, the challenge of distributing the analysis results and making data queryable for multiple users, for multiple sites. And then, of course, data governance, right? So this is where you are very concerned about atomicity, consistency, isolation, and durability, those letters for ACID. And it has to do with the fact that when you begin to move lots of data around, there are errors that can happen, and you need to have systems that are adroit at finding them and stopping that, as well as access controls and maintaining encryption. So those are some of the challenges. The way that we've implemented flexFS, which is a network file system that's cloud native, is in conjunction with SciDB as well as with burst mode. And we talked about burst mode last time that we presented. It's an elastic task service. Again, the real driver for us in creating these softwares is if we can't find open source solutions that are usable, then we'll write our own software. And so with flexFS, there are definitely open source solutions out there, but they're quite limited in their speed, in their accuracy. And so that's why we created flexFS. So it's based on the POSIX standard, but it goes beyond POSIX because it supports extended ACLs as well as a number of other really important features for pharmaceutical environment. And overall, what we're trying to do is to create this suite of apps where the plumbing, burst mode, and flex, and so forth are underneath very nice R and Python APIs with REST clients and other types of GUIs to interact with the data and the analyses without having to get into the details. So just by way of explaining the architecture, it's a file system, right? So there's nothing new here. You have hosts, you have admin services, you have metadata service, you have some kind of block file storage in the cloud because we're cloud native. So we've done most of our work with AWS, so that block storage is S3, but we designed Flex so that there are only, just like in a REST API, there's only 4 commands that it needs in order to work with any particular block storage. So it will work with Azure Blob, it'll work with Google Cloud and other hybrid systems. So I created this, put this slide together for a couple of reasons, and I think that it's really important once you move from thinking about working with one individual file to thinking about working with thousands and millions of files. And one of the things we've learned from creating distributed databases like SciDB is you chunk data, right? So you distribute chunks of data around the different server blades in the cluster, right? So this is a basic concept with distributed computing. And we've imported this concept into flexFS such that we can chunk up large files, for instance, like a large LCMS file, as an example, and distribute the blocks into flexFS in the arrow format. So arrow is Apache Arrow is a very high-speed way to move data around. And so we've elected to use that as the appropriate format. It's an open format as well. And this allows us then to store large data sets. And we've mostly done this in the genomics area, where we'd love to work with anyone in the Allotrope Alliance doing this with large MS files or any other kinds of large files that you have. These chunks then can be read either back into SciDB for presentation or coordinating analysis, or by other programs. So any kind of machine learning program can read this, right? So scikit, TensorFlow, any of those programs. And the idea is to create a spot, a single point of truth in Flex, where you have access to the files. You can sub-select, for instance, a particular range of M over Z values if it's a mass spec file, and thereby reduce your costs and improve your speed, right? Because you're just grabbing a little bitty chunk of a very large file in order to do the analytics that you want. And so we've got this working now with variant call files, the VCF files, and so we're able to support genome-wide association analyses types of workflows, and that's all in place at Alnylam and some of our other customers. So the basic concept from this slide is have a storage that actually emulates some of what we've learned from distributed compute and allows you to reduce the cost of moving data as well as doing the calculations, right? So that's the basic concept here with chunking, and it's a really exciting time for us because we've got a really interesting tool set to work with. So I'm going to present this last slide, and then I'm going to hand over to Shrikant, because Shrikant's done all the work and doing some of the simulations of what would be, the time, effort involved in moving files around. And we've done this with Flex and open to all kinds of questions. So please ask. Again, I understand that we've made this huge jump from one end of the implementation curve to the other. So we're definitely sensitive to that. So what you see here is really the reason that we wrote this flexFS. On the left, you see the timings for moving, reading and writing from a 5-client cluster into the block storage S3 or into the Elastic Block Storage EBS that they provide in Amazon, or the Elastic File Storage, as well as into flexFS. And you can see, sorry, should I be checking that? Other questions?
I'll check, Zach.
No. Okay, great. Sorry, everyone's like, what is he talking about? On the left, you see why we wrote the software to begin with, which is that we're looking at a 5-client cluster here, but we routinely scale our computations to hundreds of clients. So we'll get up to as many as 500 workers. So that means a client that has a worker has 48 cores in it, right? So it's the cluster, and it's quite a big amount of compute in AWS, and you're actually constrained by bandwidth with limitations at that point. You could add 600 or 700 workers. Our software is fine with it. It's just you don't get any improved computation. So at the 5-client level, you can see a very discernible increase in performance using Flex now. All right, so let me hand off to Shrikant. Just let me know, Shrikant, when you want me to begin.
No, this is great. Hi, thank you, Zach. Hi, everyone. Thanks for this opportunity. So just continuing on what Zach was talking about in terms of the multiple clients accessing the data, right? So what we tried to show here is, there's the concept of, as you keep increasing cluster size, getting bigger and bigger machines, and then the problem sort of goes away, right? So, and that's what we noticed that with EFS, often it wasn't the case for large files. So we did this benchmarking using a 6 GB file, where we increased the cluster size, and when we measured read and write performance throughput, using both flexFS and EFS. So these are on a pretty large EC2 instance. It's mentioned on the slide, the C5N 18x large. And the values show this exponential increase. So it's a multiple of how much better flexFS performance is compared to EFS. So this was an interesting way to for us to position Flex performance relative to EFS. Next slide, please, sir. Right, so in this slide, what we wanted to do is we wanted to outline a use case for flexFS and the Allotrope tools. And this is looking at a very typical single site QC workflow, right? So on the left, there are multiple instruments such as LCMS, LCUV, and these are generating data which get converted into the ADF files. And then these get injected into, for instance, a flexFS backed data server. Now, it is S3 backed, unlimited data storage, all of the cost effectiveness comes into play here. And then using the ADF input output APIs, these data sets can then be accessed by multiple users across the site. And this is where flexFS's ability to serve concurrent users, right? Multiple high clusters accessing the data simultaneously, and it does that with a very high read-write throughput. So this is where we feel that tremendous benefit towards optimizing workflows such as these. Next slide, please. Right, so then we took this concept of a single site workflow and we scale it up. This is what, in terms of the slides that Zach was presenting for the burst mode scalability, as well as Flex, right? So this is where we excel. And this is an example of that. So we take that single site workflow and we multiply that out where multiple sites with various different instruments. And again, this is where the federation that ADF does with multimodal data comes really handy. And data is then going into a single point of truth. So that's the Spot server, and this is the data commons, flexFS backed. It can be talking to something like a database or an analytics layer. In our case, it's SciDB, where you could be doing in-database computations. So big linear algebra calculations or simple things like Levy-Jennings graphs and things like that, which are useful for QC. And then from this data commons, you have multiple sites with hundreds of users who are ingesting this data through the ADF input-output APIs. And a scenario like this, where there is significant growth in data over time, hundreds of concurrent data requests, input-output requests, and then there's this need for easy data availability for reuse for, let's say, generating reports on instrument performance. And these are great use cases that that we think where flexFS can really shine. Next slide, please. Right, so this is from a number. These numbers are actually from the proteomics, the Australian Proteomics Institute ProCan, where they were essentially there's I think it's a 5 or 7 year program where they're generating both pathology image data as well as proteomics, mass spec proteomics data. So we wanted to illustrate here that what's the outlook of data generation and growth over time, right? And as you see, it can get up to tens to hundreds of terabytes of data. And this is, and then you have versioning, you could have processed it differently. So overall, over the period of a few years, you see exponential increase in data that is generated and needs to be stored cost effectively, which brings us to the right panel. So this is, and you see the different caveats and the points illustrated in the bullet points there, that these are the estimates that we generated for storage of 50 terabytes of file data. And this is actively accessed data. So so it's not like a cold storage where you have an object store and not a file store. And then these comparisons are made at the M5 2x large instance. obviously happy to provide more details.
And I think, Shrikant,
Mm-hmm.
I think it's important also to point out that that's 50 terabytes of compressed in Flex. So if you actually had the 50 terabytes from EFS, compression
that's
would be at least 10 to 30 fold.
Right,
So,
right.
You know, actually a really dramatic cost reduction.
Right. Next slide, please. Yeah. Yeah, so this is, we wanted to put this up on an ease of use, user friendliness part of the software, right? So installing and mounting a flexFS volume is very straightforward. So that's shown in the left panel. And once it's finished, it just shows up as a typical file directory. So then what I was thinking is I could do a little bit of, I could show a little bit of a demo where I would show some file operations in a flexFS volume. So this is to show that it behaves as a file system. So if I could get access or the presenter status, that would be great. Thank you. Right, so what we have here is trying to illustrate somewhat of a situation that we on the QC workflow, right? So on my left side, so this is our flexFS backed system. This is our server. This is where the data is coming in, and you see here we have this show up. The flexFS mounted system shows up as a typical file directory. I have some. Let me just do, so what I did was I wanted to show you how we just work with, so I'm just gonna, right, so we can look through using just HDF5 functions. We can look through the example data set, which is something that I picked out from Allotrope portal. We can take a look at the different data sets within the file, within a particular group. And other simple things like we can look at the data set in the table, so gets you the actual raw data. We can view contents of a specific data set. So this is, again, these are just simple file operations just to give the sense of that, okay, we are working with the file system, right? Like we are working with these large LCMS files. And then finally wanted to just show how we can just create a subset, right? Like, and it shows up here. There's another folder with more data. And then let me just do a quick, just copy this file over from our, right? So this should show up here, right? So that's the file up here. So I'm not sure if obviously we can use the Q&A for sessions, but that's what I wanted to show from the perspective of how we use flexFS. Very uninteresting in some ways. It is a file system, and obviously happy to answer any questions with respect to performance and things like that.
Yep, and I guess we have one conclusion slide.
Yep. Should I bring that up, Zach? Since I'm sharing.
Sure. Yeah.
Oh. One second. Is that coming through? Oh no, let me just reshare.
Yeah, great. So I hope today's talk, we kind of established the baseline of why digitization will require elastic data management and elastic analysis. We know there are many strategies for achieving elasticity, and we just talked about one, and that we tried to show the comparison of the scaling capability of Flex versus EFS in AWS, and the comparison to scaling show the advantages of a solution with parallel read and write capabilities. So whenever you're thinking about doing calculations in the cloud with workers, you're always forced with how do we feed them, so how do we upload, read, and then how do we download right into whatever you're going to store the results into. And we think that there's a lot of opportunities for savings. And you know, we're happy to work with anybody in the Allotrope group and community on this. We're trying to develop a system where any kind of software can read into Flex and pull files out of Flex. There should be no barriers. And with the chunking, as we develop that further, we think that offers really big opportunities for savings, especially in with mass spectrometry and other large file system analytics. So thank you very much for your time. I hope this was interesting. I know that it's very different from what the other talks are about.
Thank you.
Great, thank you both.